So good evening everyone and welcome to this lecture. We are into transverse wave. We have started wave motion in the previous class and we are dealing with transverse waves. In the last class we had seen what we had seen in the last class. Yes.
About mediums, sir.
Yes, we had seen the basics of waves. We had seen what are the types of waves and how they are classified. We had seen the classification. Do we remember the classification? Waves are classified based on their necessity, based on propagation, based on how many dimensions the wave is moving, and so on. Do we remember this? Then we had seen the various types of classifications, and we had seen transverse waves where particles oscillate perpendicular to the direction of propagation of wave. And this is the first wave that we are going to study. Uh, in this class, transverse waves. But before going on to transverse wave, let us first take a note of the other type of wave also, because we would be doing the terms of the wave first, and whatever be the type of wave, the terms remain same. So let us first go through those terms. Let us first just have a quick discussion on the longitudinal waves. We have seen what are transverse wave. In transverse wave, what happens is the particles oscillate perpendicular to the direction of propagation of wave. What happens in longitudinal waves? In longitudinal waves, the particles will perform SHM in the same direction as the direction of propagation of waves. So if the wave is propagating along x-axis, the particles will also be oscillating along the x-axis. Do we understand this?
Yes, sir.
Now, we have to also remember the difference between longitudinal wave and transverse wave. Transverse wave we had seen, apart from the direction of propagation of particles, the transverse wave propagates in the form of crest and trough. Yes or no? Crest up, trough down. That is how it propagates. Does anyone know how does longitudinal wave propagate? Any idea how does a longitudinal wave propagate? Propagates by the phenomena or the concept of compression and rarefaction. What is this compression and rarefaction? Anyone? Are you able to hear me?
Sir, it is both longitudinal and
Both longitudinal and what?
longitudinal and volume something.
Both longitudinal and volume. What happened? Any doubt?
No, sir.
Okay. So this longitudinal wave, and the best example for longitudinal wave is sound waves. The best example of longitudinal wave is the wave that you are listening my voice. So that is a sound wave. Sound wave is the best example for a longitudinal wave. It propagates by the phenomena of compression and rarefaction. What is the compression and what is the rarefaction? Any idea? So the compression, and we will understand this term very nicely when we go into longitudinal wave. Compression is the region where the particles are very close to each other. Now, in this medium, right now I'm sitting in a room. There are a lot of air particles in the room. Now, they have their mean positions. They have some distance between them, normal distance between them. But when I'm creating a wave, sound wave, because of this sound wave, the air particles at some places are going to get compressed, or they will be more in numbers. The density would be more. That region is known as compression. And in some places, they are going to be far apart from each other. That region is known as rarefaction. Now, to understand this compression and rarefaction, I can give you a diagram, and that diagram probably will help you in understanding how this compression and rarefaction are there. So, this is the diagram that comes on your screen now. You can see this particle. There is a wave which is traveling here, and at some points you see particles are very close, and some points you see particles are far. The points where the particles are close is known as compression, and the points where the particles are far apart is known as a rarefaction. Do we understand this?
Yes, sir.
Compression and rarefaction. Why does this happen? Because the particles is oscillating in the same direction as the wave, and therefore at some points the particle come close to each other, and at some points the particle go away from each other, and therefore we have this phenomena of compression and rarefaction. Do we understand this, everyone?
Yes, sir.
This is the phenomena of compression and rarefaction in longitudinal wave. What are the example of longitudinal wave? Whenever we come across longitudinal wave, the first thing that will come to our mind is sound wave. Now, apart from sound waves, we are going to see one more thing. We will be seeing vibrations in air column. In longitudinal wave, we will be doing this chapter. We will be doing this topic. Don't worry. But right now, you can just note down. There are two good examples of longitudinal wave. Sound waves traveling through air are in the form of longitudinal wave. Vibration of air column, and we'll see what is this vibration of air column in organ pipes. That is also longitudinal in nature. Now remember, transverse wave, as we saw, what very difficult to make in liquids and solids, liquids and gases, but this longitudinal wave can be made in solid, liquids, as well as gases. Sound can travel in solids, sound can travel in liquids, and sound can also travel in gases. Yes or no? In fact, the speed of sound is fastest in solids. Do we know this? Yes or no? So, longitudinal waves can travel in solids as well as liquids as well as gases. I'll give you 2 minutes to note this down. Everything that we are noting down is a potential question in itself. Please remember that. I'll give you 2 minutes to note it down. Okay, then. Now, whether the wave is transverse or the wave is longitudinal or the wave is EM wave or any type of wave, there are some terms that we will have to understand before taking our next step. And what is the term that we are going to understand? The first term is known as the wavelength of a wave. So that is what you are going to write. Wavelength of a wave. All these terms, this entire chapter is all about understanding the terms and understanding the wave equation. If you understand the term and you understand the wave equation, this all chapter is about that. Nothing else you have to understand. Wavelength. What do you mean by wavelength of a wave?
The distance between two successive thrusts or troughs.
The distance between,
Two successive thrusts or trough.
and what about longitudinal wave? There are no wavelengths in longitudinal wave.
Between two compressions, middle point of compression.
Not to
Rear,
rarefaction.
rear fraction also, sir.
That is it, and this is the diagram that shows you that. So you can you can define it in many ways. You can define it in many ways, and I will just try to put them. The first way you can write it, it is the length of one wave. How long is one wave? Length of one wave. This is one way of writing the same thing. The next way of writing the same thing is, it is the distance traveled by the wave in one time period. When I say one time period, what do I mean? The particles of the medium are oscillating. The particles of the medium are oscillating. They may be oscillating in the same direction, they may be oscillating in the perpendicular direction. SHM, you remember time period, na? Uniform circular motion, SHM time
Yes, sir.
period. In one time period, how much distance the wave moves, that is also known as the wavelength of a wave. Or as you said, it is the distance between two successive crests or two successive troughs. Well, you may not have to call them crest or trough. You can simply call them two particles in the same phase. It may not be between two successive crest or two successive trough, or two successive compression or two successive rarefaction. Between any 2 points which are in the same phase. And remember, the very important thing that comes here is phase. And since we have already understood phase, we will be able to understand it more clear here. Remember, there is nothing different between simple harmonic motion and this wave, because both are in the form of sine or the cosine waves. Do we understand this, or this is going above our head saying bye bye?
Understood, sir.
Or you can say distance traveled by wave in one time period is known as the wavelength. I hope everyone is noting it down. Yes or no? No, yes.
Yes, sir.
You don't have to write everything. If you have understood something, just understand it in one way and you will be doing good enough. Have you noted this down?
1 minute, sir.
Okay. Wavelength, whatever ways you understand it, whether you call it length of one wave or the distance traveled by the wave in one time period, or distance between two successive crests and two successive troughs, or distance between two compression, two rarefaction, everything is same. Do we understand this?
Yes, sir.
Okay, so I hope you have understood this. Shall we move ahead?
Yes, sir.
Okay, what is the next thing that we will have to understand? Next term. Yes. Ah?
Frequency, sir.
Frequency is the next term. Frequency is the next term. So what is this? Number of oscillations?
In 1 second.
Number of oscillations in 1 second. How many oscillations it is doing in 1 second? It is denoted by the letter F, frequency. Then the next term all of us know is time period. Yes or no?
Yes, sir.
denoted by the letter capital T. First, listen to me, then I'll give you time to write. It is the time taken to complete.
One oscillation.
This is the time taken to complete one oscillation. One oscillation. Then you have the relation between frequency and time period. What is the relation?
F equals to 1 by T.
F is equal to 1 by T. Well done. F is equal to 1 by T. Then the next term that we are going to see, first understand these terms, then you write them. Angular frequency. Remember, we are not calling it angular velocity. We are calling it angular frequency, omega. Angle turned in 1 second. Do we understand this?
Yes, sir.
And this omega is nothing but 2 pi f, or it is 2 pi by t, angular frequency, omega. Are we understanding this, or this is going above our head saying bye bye?
Understood, sir.
What is the next term? I'll write all those terms so that amplitude of the particle. Remember, the particle is performing SHM. What is the amplitude of the particle? This is maximum displacement. Do we understand this?
Yes, sir.
Maximum displacement from the mean position is known as the amplitude of the particle. Yes or no?
Yes, sir.
Okay. Then I will just write it here only so that in one screen you have everything. Then we have angular wave number. Angular wave number k. Angular wave number k. What is this angular wave number k? This k is nothing but 2 pi by lambda. Angular wave number. Then you have something known as a wave number. Then you have something as a wave number. We can call it as n. Wave number n. This wave number n is 1 by k. So it becomes lambda by 2 pi. This wave number we will not be using. Oh, this sorry, it's not 1 by k. I'm writing. It is 1 by lambda. It's 1 by lambda. So you can write it as k by 2 pi. This wave number we may not be using much, but so sometimes they ask you what is this, what is that. You should be able to recollect what we have done. Do we understand this? Have you noted this down?
Yes, sir.
Let me just make a small thing here only, and I can write the next term. Is known as the wave velocity. Wave velocity, which is written as v. Now remember, this wave is going to travel in a medium, and in a medium it will be traveling with some speed. That speed is known as your wave velocity. Do we understand this?
Yes, sir.
Now there is a relation between v, f and lambda. We have been using that relation. What is the relation between v, f and lambda? V is equal to f lambda. Do we remember this relation?
Yes, sir.
Okay. Okay, wave velocity. Now, now we might get confused between one more term which looks like this. There's a velocity. See, we have to understand that there are two things happening simultaneously. The wave is moving with a definite velocity. This velocity of the wave depends on at what is the frequency of the wave and what is the wavelength of the wave. Basically, it depends on the medium and the source which is creating this wave. My sound that I am creating, I am the source. It will be my frequency and my all these things will be creating a different sound. Yourself, when you are speaking, you are creating a different sound because of different sources. The frequency of the sound depends on the source. If I am the source, whatever frequency I am giving a sound, that is my sound. Then again, sound, the speed depends on in which medium you are talking, in which medium that wave is traveling. So the speed of the wave depends on two things. One is the source which creates the sound or the wave, at what frequency he is creating, and in with what wavelength he is creating. Is wavelength and the speed of wave depends on different mediums. Yes or no?
Yes, sir.
Okay, that is one thing. We have one more thing which is known as the particle velocity. Particle velocity and particle acceleration. What is this particle velocity and particle acceleration? Now, when this wave is traveling with a certain speed, which depends on other factors, medium, source, and all that, this particle are also oscillating. If it's a transverse wave, they are oscillating in the perpendicular direction, perpendicular to the wave. If it is longitudinal wave, it is oscillating in the same direction. Yes or no?
Yes, sir.
The velocity of any particle may not be same as the other particles, and there are infinite number of particles here. Their individual velocities and their individual accelerations are known as particle velocity and particle acceleration. So particle velocity and particle acceleration are nothing but the acceleration of individual particles which continuously keeps on changing because they are oscillating simple harmonically. But the speed of the wave does not change unless and until you change the medium or you change the source itself. Do we understand this?
Yes, sir.
Or this has gone above our head saying bye bye sir, bye bye sir, I'm going sir, bye bye sir.
Understood, sir.
Paka?
Yes, sir.
Okay. That takes us to the next topic. Now, shall we move ahead?
Yes, sir.
Okay, we have seen
Sir, there are no formulas for VP and AP, sir. Or they are same as in SHM. That A omega sine omega t phi by that one.
wait, let's wait. Now, we have seen types of waves. We have seen transverse wave, we have seen longitudinal wave. In transverse wave, particle oscillate simple harmonically perpendicular. In longitudinal wave, they oscillate in the same direction. Now, we had also seen one more classification of wave, and that classification came from whether the energy is getting transferred or not. Yes or no?
Yes, sir.
That is the next type of wave that we are going to understand. A traveling wave or a progressive wave. Traveling or progressive wave. Traveling or a progressive wave. A wave which is traveling, which is moving. Traveling or a progressive wave. Now, how do we write the equation of a wave? How do we write the equation of a wave? Now we come to the part where we get into the point where we have to understand how a wave equation is written. Now, when we wrote the equation of simple harmonic motion, that was a simple harmonic motion of one particle only, right? Y is equal to a sine omega t, or y is equal to a sine omega t plus 5, or whatever. That was the equation of only one particle. But here we have to write the what? Equation of a wave, which should tell us the position of all particles in the medium at all times. Do we understand this? There is not a single particle that is moving. There is not a single particle that is moving. There are a lot of particles that is moving. So what will be the general equation of any wave? What will be the general equation of any wave? In what form will be the general equation of a wave? The general equation of a wave will be in the form like this. Y xt will be equal to f of ax plus or minus bt. It now starts to look very complicated. Starts to look very complicated now. Why it starts to look complicated? Because it will be a function of both x. If I have to write the equation of SHM of any particle, the equation of SHM of any particle, let me write the equation of SHM of any particle. The equation of SHM of any particle can be written as y is equal to a sine omega t plus 5. This will tell us the position of this particle at all times. Yes or no?
Yes, sir.
But here in the equation of a wave, there is not a single particle. So this y basically, which is telling us the position of one particle with all times, I have to write the equation of all particles at all times. So first of all, I have to find out which particle I am writing the equation. And that particle will be present somewhere on the x-axis if I am assuming that the wave is traveling along x-axis. Do you understand what I'm saying here? Therefore, the equation of SHM is only the equation for one particle. This is the equation of one particle. This is the equation of one particle. I have to write the equation of all the particles. I have to write the equation of all the particles at all times. I have to write the equation of all the particles at all time. Now, how will I write the equation of all the particles at all times? Who can tell me this? How can I write the equation of all the particles at all times? I can try it like this. Y is equal to, remember, and here we are assuming that all the particles are having the same amplitudes. Okay, are having the same amplitudes. A sine omega t minus kx, or I can write it as kx minus omega t also. Doesn't make much of a difference. Now this becomes the equation of a traveling wave, which gives us the position of all particles at all times. How does it give us the position of all particles at all times? If I want to find out a particle at x is equal to 3 meters, at time t is equal to 5 seconds, where is that particle? So I put the value of x as 3 and time as 5 seconds, and I will get the position of that particle. Do we understand this?
Yes, sir.
Do we understand this? Here, the terms that come in this equation, A, what is this A? What is
Amplitude
this?
of the wave.
Amplitude of the wave. This is not the amplitude of the wave. Wave does not have an amplitude. Did I ever say wave has an amplitude? Who has an amplitude? The particles which are oscillating, they have an amplitude. Wave does not have an amplitude. So this A is the amplitude of oscillation of the particles. Are we able to understand this?
Yes, sir.
What is this omega?
Angular frequency of the particle.
Okay, it's not angular frequency of the particle, it's also angular frequency of the wave, because all the particles have the same angular frequency. That is known as the angular frequency of the wave. Okay, what is t? T is time. At what time what particle where is? What is k? Yeah, k is 2 pi by lambda. That is known as the angular wave number. And what is x? X is the position of the particle on the x-axis. Do we understand this?
Yes, sir.
This becomes the first form of equation of a traveling wave. Now, since we know the relation between different terms, we can write this equation in different ways, and you will have to remember all those waves. Sine of omega t minus what was k? K was 2 pi by lambda, yes or no?
Yes,
Into
sir.
x. Equation number 3, y is equal to a sine of omega t can be written as 2 pi by t into t minus 2 pi by lambda into x. Are we able to understand what I'm writing here? Y is equal to a sine, I can take 2 pi outside, 2 pi outside, t by capital T minus x by lambda. Are we able to understand this, or this is going above our heads?
Understood.
First, first, first see what I'm doing. Then I will give you time. You can note it down. Okay. First, give me chance to write it down, and then you can, then you can write down on your own. And it will be better if you write them on your own. First, you see it. Okay. Now, there was a relation that we saw between V, F, and lambda. There is also a relation between omega, V, and lambda. We can also find out that relation. Yes or no? See, your V was F lambda. Your F is the frequency. How can you write frequency? You can write it as omega by 2 pi. Yes or no? So I can also write omega as 2 pi V by lambda. You will have to remember all those relations, because every relation comes from each other. Now, if I write it like this, then I can write the wave equation in the fifth form. Y is equal to A sine, I can take 2 pi by lambda outside. I write it as Vt minus x in terms of the speed of the wave. Do we understand what I've written here? And then using the same relation, same equation, I can write it in this form. And again, there are more permutations possible, but these are the most appearing forms in which I have written the equation. Sine of, you can take omega outside, t minus x by v, t minus x by v. If in a general form, you have equation of this written as a sine of ax minus bt, or bt minus ax, or at minus bx, doesn't matter. You can write the speed of the wave as coefficient of t divided by coefficient of x. So whatever is there with t, you divide it by whatever is there with x, and you should be able to get the wave speed. I'll give you 5 minutes. If you remember any one of these equations, 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 you would be able to write the other equations. And the entire chapter relies on whether you remember these equations or not. So I'll give you 5 minutes. I'll give you 5 minutes. Go through these equations one by one, memorize them. 5 minutes. So we have written the wave equation, and I'll still keep them. There are some important points between that you have to remember about the wave equation. So you can write the next heading as important points. Try to summarize everything that we have seen. Important points. Okay. And what is the first point that is going to come? And that creates a lot of confusion many a times.
You're not presenting.
If the sign between the t and the x terms is negative, then the wave is traveling in the positive x-axis. So if you have a wave written like this, y is equal to a sine omega t minus kx, whether it is written in this form or it is written in this form, y is equal to a sine kx minus omega t. If a negative sign comes in between them, this wave is traveling along positive x-axis. This wave is traveling along positive x-axis. If your equation of the wave is written like this in any form, and the sign between them is positive, then that means that this wave has to travel along negative x-axis. Then we had seen the term called phase. Whatever comes inside this sine and cos, omega t minus kx or whatever, that is known as that is known as the phase of the wave. It's not the phase of the wave, it's the phase of the particle of the wave. Of what particle you are talking about. Now, very important point here. Point number 3. Whatever you see with t, the coefficient of t, if you just remember this, everything becomes simple. If you remember the coefficient of t, the coefficient of t will always give you omega. Omega is 2 pi into f, where f is the frequency, or it is 2 pi by capital T, or it is v, the wave speed multiplied by k. Everything, all the equations written in one single line. Beauty of this. Beauty of this. Beautiful. Similarly, if you can remember it in this way, what does the coefficient of x give you? The coefficient of x gives you the value of k. And if you remember what was k, you will get all the equations. 2 pi by lambda, k is 2 pi by lambda, or it is omega by 2, omega by v. Everything written in 2 lines. I can write the same thing in this way. The relation between coefficient of the ratio, it's not ratio. If you divide the coefficient of t by the coefficient of x, it will always give you v, because v is omega by x, omega by k. I hope we are able to understand this, or this is going above your head saying bye bye, bye bye. When the wave travels from one medium to the other medium, one thing always remains constant, that is the frequency. Why the frequency remains constant? Because frequency depends on the source. Unless and until you change the source, you will not be able to change the frequency. When a wave travels from one medium to another, frequency remains same. What changes is the wavelength, and since the wavelength changes, the speed of the wave also changes. Because v is equal to f lambda, we have seen that. So we can have a relation between the speeds and the wavelengths in the two cases, and this is how you can find out the relation. V is equal to f lambda. V is directly proportional to lambda if frequency f is constant. V1 by V2 will be equal to lambda 1 by lambda 2. Do we understand this?
Yes, sir.
One more thing you can write, and then I'll give you time to write. Relation between phase difference, path difference, and time difference. Phase difference delta phi by 2 pi is equal to path difference delta x by lambda is equal to time difference delta t by capital T. Do we remember this relation? Yes or no? No or yes? Do we remember this relation? I'll give you 2 minutes to note this down. So now let's move on and see some questions based on this. Remember, 2 or 3 types of questions normally come. One type of question is based on wave equation, and the other one is based on harmonics. These are the 2 type of question that I have seen come more often or not. So let us first concentrate on simple questions on wave. Then remember, we have still not covered one thing which is known as your particle velocity and wave velocity. So we will come to that. Let us first solve simple questions, and let me start with this one. So this is the first question. The speed of a wave is given 3600 waves past certain point of medium in 1 minute. What is the wavelength? You have 2 minutes to solve it.
16 meters.
And the answer is 16 meters. How did you get it? Congratulations.
Sir, number of waves passes through a certain point of medium in 1 minute means frequency of waves in 1 minute.
Yes, that is the frequency. We have to find out the frequency per second.
Second, yes.
So you just would,
Divided by 60.
yeah, so just divide it by 60, and then you put V is equal to F lambda, and you are done. V is known, F is known. You can calculate the value of lambda. Do we understand this? Yes or no? No or yes?
Yes, sir.
Okay. Here comes the next one. We have to just understand the wave equation. The more the number of questions we'll do, the better we will be able to understand the wave equation. The frequency of a sound wave is f or n, and its velocity is v. If the frequency is increased to 4 times of n, what is the velocity of the wave?
V, sir.
V? Why not 4v? V is equal to f lambda. I make frequency 4 times, speed of the wave will become 4 times.
Frequency is constant, so
Frequency is constant?
Frequency is increased, bro.
You have not read the question carefully, my dear friends.
Frequency is increased by
I've increased the frequency, my dear friends. Ding, ding, ding. See? Good question, no? What is the answer? You don't have to use copy pen for that. Either you know it or you don't know it. Yes. V is equal to f lambda is the only equation that you know. Now, if I make the frequency 4 times, what happens to the lambda? What happens to the speed of the wave? Huh? Still waiting for your answer, bacha. Huh? No answers. And the answer is
1 minute.
why you want 1 minute for this? What you have to think? You tell me that. And then I'll give you 5 minutes, not 1 minute. Yes, what is the answer? And the answer is no one has the answer yet. Shall I do it? Huh? Well, if you're thinking so much, I'm sure that you don't understand the question. And the answer is the speed remains v only. It does not change. And that was first answer that you gave was correct. And I thought that you have thought what the correct reasoning is. Remember, frequency depends on the source. But the speed of sound, sound, because speed depends on the medium, in which medium it is traveling. It does not depend on the source. Now, what is the best example that you can do, that you can give for this? Uh, I don't know how you have lived your childhood, but when I was of your age, not your age, I was in fifth or sixth or seventh standard. I used to live in a place where there was a railway track right in front of my house, and my house was like 5 meter, 10 meters away from it. Railway track. Train used to go gar, 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 and we used to see gar, 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 and every time the trains to go gar, 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 we used to get awake, get awoken. Now this train is going, and we used to play this game on the train, that some person used to go very far off with a small hammer or something, and then he used to bang on the train, on the rails of the train, and we could hear the sound far off, right, far off, and we could hear the sound of the train. We could not even see the train, we could not hear the actual sound of the train, but we used to put our ears on that dirty rail, and there was not dirty, on dirty rail. Oh, the sound is coming, that means the train is coming. The sound of the train was not coming through air, the sound of train was coming through what? The railway track, and it was traveling way faster, the speed was faster, the train was creating the same sound, but when it was coming through air, it was coming slower. When it was coming through the rail, it was faster. Speed of the sound does not depend on the source or the frequency, my dear friends. Do we understand this, or this has gone above our thing? Bye bye. Bye bye. Bye bye. I told you that also. Speed depends on the medium. If you change the medium, then only your speed changes, because the wavelength changes. Do we get this? Yes or no?
Yes, sir.
Pakka?
Sir, I have one doubt. If you
Yes.
are increasing the volume, that means you are increasing the frequency, sir.
Yes, but the speed of sound does not change. With
I'm
it.
asking, sir, is it same?
Yes,
Increasing
yes.
volume and increasing frequency is same.
Yeah, you are increasing the volume. You are not increasing. Frequency means how many oscillations are happening 1 second. You are increasing the volume, you are changing the decibel levels of it. Not changing. Frequency is different. At what frequency you are talking? Now see, I'm going to talk very fast. No, 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 no. This is the frequency of my wave has changed. Got my point? The
Yes,
loudness
sir.
and the volume is different. It depends on the energy. Okay?
Okay, sir.
Frequency is number of waves I am sending per second. Okay? Do we understand this, or this is gone above our saying bye bye? Bye bye? Bye bye, na? How many people got bye bye on this? Do we understand this or not?
Yes, sir.
Okay, now see the concept. Slowly, we are moving towards understanding waves. This one. This is the question. Now, with this question, you probably understand what this wave function is all about. Marvelous thing. A simple harmonically progressive wave is given by the equation y is equal to 8 sine 2 pi something something something, when x and y are in centimeters and t is in seconds. At any instant, the phase difference at any instant, that means at any instant, that means at the same time. Do we understand this? Huh? At any instant, what is the phase difference between two particles separated by a distance of 2 centimeters on the x-axis? Phase difference. I'll give you 2 minutes to give me the answer. There are two ways of doing it. I'll use the simplest one first.
Sir, okay, sir. It is y equals to a sine omega t plus phi. That's it. That is, sir.
Okay, so I'll tell you my way of doing it by equating this equation, by comparing this equation with the standard equation, and by giving you 7 standard equation, you can find out what is the wavelength of this wave. Yes or no?
Yes.
Can anyone tell me what is the wavelength of this wave? That is what you have to do. Compare it with the correct equation, or compare it with any equation. You will get the wavelength of the wave. The coefficient of x give you the value of k, and k is 2 pi by lambda. From there you can get the value of lambda, and the value of lambda will be 10. Yes or no? You will have to understand the equation. Do you understand the value of lambda is 10? No one understands this. I can write this equation like this: 8 sine 2 pi by 10 into x minus 4 pi t. This is the coefficient of x.
Sir, that means the sign, it doesn't depend upon sign between them, sir.
It does not depend on.
I mean that it if sine omega t plus phi or phi minus omega t is same, sir.
It's not phi here. It is in terms of kx and t. Phi has not come here.
Okay, sir. If it is kx minus t,
Then omega is 1.
then if it is omega t, t minus kx,
What are you saying? I don't understand.
sir, I am asking that if the terms in the bracket, that is sine coefficient, is exchanged, then
What did we write, beta? What did we write here? Please read this pink one. What did we write here? What did we write here? Please read this one. Please this red one. Please read this one, and please read this one. The problem with you guys is that you just write and you don't understand anything. And then you
sir,
write quickly and then you say that you understand everything.
sir, I am asking that the signs are taken into consideration or not.
Has anything been written about the sign?
I don't know, sir, because I am seeing this for the first time.
That is why I said na to read it carefully. What difference does it sign make? I have written all the equations here. I have written all the equations here. Did I say anything about the sign? What does sign tell you? That is given in that part. What do we understand from that sign in between those two? Do we remember this? Do we remember what we understand by the sign? Why is sign troubling you? If there is a negative sign, what does that mean? Did you write this equation or not?
Sir, that means we only consider the magnitudes.
Do you understand what difference does the sign make?
Yes, sir.
That's it. That's it. Have you ever heard about negative angular frequency? Negative time period? Negative wavelength? Ever heard about these terms? No, no?
No, sir, but we have heard about negative velocity, no, sir.
We have also heard about negative acceleration.
Yes,
We
sir.
have also heard about negative force. I have a velocity of negative 2 meter per second. What does that mean? I have a velocity of plus 2 meter per second. What does that mean? It means nothing. If you don't remember that from the first class, let's not get into that part. Okay, so lambda here is 10. You can just compare it with any of the standard equation. You will have to remember those standard equation. Nothing can be nothing will get in the way of this. The coefficient of x gives us the value of k, and the value of k is 2 pi by 10. So 10 becomes your lambda. So now I know the value of lambda. Now we have seen the distance between the particles is 2 centimeters. So this distance between the particles, which is given as 2 centimeters, can be taken as their path difference, because they are away from each other by 2 meters, 2 centimeters. So the path difference is given, and from there you have to find out the difference in phase. So we use the equation delta phi by 2 pi is equal to delta x by lambda. From here you will be able to calculate the phase difference. How will I get the phase difference? Delta x will be 2 pi by lambda. Lambda is 10 multiplied by 2. So that gives me how much? 2 pi by 5 radians, and 2 pi by 5 radians I think will come as 2 pi by 5, 2 by 5 into 180 degrees. That I think should come as 72 degrees. So that is one way of doing it. The other way of doing it would be this. At any time, so time you can put this time as 0 also, just to make things simple. At any time, at any instant, so you can put the value of this time as 0. You can put the value of this time as 0. Two particles are separated by 2 centimeters. So for the first particle, you can write x as 0. So the first particle equation becomes 8 sine. If I put time as 0, oh, let me not put time as 0, because then everything becomes 0. So I can write it as 8 sine. Let me put x as 0. If I put x as 0, and let me write the equation in form of omega t minus kx, because it does not make any difference. So I can write it as omega t, and omega is given as 4 pi. So I can write the first equation by putting the value of x and t as this one. Then for the second particle, same time, instead of putting x as 0, I will put x as 2, because they are separated by 2 centimeters. So for that particle, the equation looks like this. 2 pi by 10 into 2 plus, oh, I will have to write it in the same form. So 4 pi t minus 2 pi by 10 into x. I've just switched over the sign. I just want to find out the phase difference, nothing else. Now, if you subtract these two, this time wala factor will get cancelled out, and this would be the phase difference, which is what exactly we got from that answer of phase difference versus path difference. So the actual way of finding the phase difference is this. If I have an equation of the equation of wave as like this, and please note it down, and I'm just writing a general form. If I have the equation of a wave like this, and I have to find out the phase difference between two particles at two positions at two different times. Remember what I'm saying, two particles, two positions at two different time, then what will be the phase difference coming? The phase difference will be coming as omega into t1 minus k into x1. That will be the phase of the first particle, minus omega into t2 minus k into x2. Do we understand how I found out the phase difference here? Why this equation and the equation that I have written are looking same? Because the time is same. If the time is same, this will get cancelled out and you will again get the same result. So if any question comes to find out the phase difference between 2 points, two particles at two different positions at two different times, this is how you find out. And this is exactly same as what we had done in simple harmonic motion. Entire thing that comes inside the bracket is the phase of the particle. You put the value of x, you put the value of time for first particle, you put the value of x, you put the value of time for the second particle, you subtract them, you will get the phase difference. Do we understand this?
Yes, sir.
Everyone got this? How did I get the value of phase difference? Yes or no?
Yes, sir.
Okay. And remember, whether you write the equation as kx minus omega t or omega t minus kx to find the phase difference, it does not make any difference. Whenever you have a negative sign in between, that is equation of a wave traveling in the positive x-axis, nothing else. If you have a positive sign, that means it is equation of a wave traveling in the negative x-axis. We understand this, everyone?
Yes, sir.
Okay. I'll give you 2 minutes to note this down. Do it fatafat so that I can do one or two more questions. This is the next equation. Now, before solving this equation, tell me in which direction is this wave traveling? In which direction is this wave traveling?
Positive x-axis.
Okay. So to find out that, what do? You look at the sign between the t wala term and x wala term. Do we understand this? If there was a positive sign here, it would have been traveling in the negative x-axis. Do we understand this?
Yes, sir.
It does not depend on whatever is here because this is just the initial phase. The wave may not be starting from t is equal to 0, x is equal to 0. It may not be starting from there. Do we understand this? Yes or no?
Yes, sir.
So this is a wave traveling in positive x-axis. Find the speed of the wave. So I'll give you 2 minutes to do it. So the answer is
A, sir.
no negative, no sir. No positive, no sir. Okay. So basically what you have to do, you must understand that whatever comes with this t is omega and whatever comes with this is k, or to find out the velocity, you just divide the coefficient of t by the coefficient of x. So it is simply 7 pi divided by 0.04 pi. Do we understand this? Yes or no? No, yes.
Yes, sir.
Okay. One more. Understand the basic wave equation. If you understand it, it's a wonderful thing that you are getting the SHM of
Sir,
all the particles at all the time. Just
sir, when velocity doesn't have to do anything with the initial phase, sir.
no. It has got nothing. It has only got to do with the medium. Nothing else. We are
Okay,
not
sir.
talking about velocity of the particle yet. We're only talking about the velocity of the wave. This is the next one. A wave is represented by the equation of this. It is traveling in the positive x-axis. In which direction it is traveling? Eh?
Negative of x-axis.
Negative x-axis. It is traveling around negative x-axis. What is the velocity of this one?
A, sir.
Yes, sir. Do we understand this now, sir?
Yes.
You don't have to do anything. You just have to look at what is happening and how it is happening. Now comes this one. What is the path difference between the two waves? Basically, they have created two different waves. I mean, they are not writing it as one wave and the path difference between two particles. They have written it as two waves, and they are asking you the path difference between the two waves. Take a deep breath and do this question aram se. They are asking you the path difference. Remember, they are asking you the path difference. Remember, I'll give you 2 minutes. So, my dear friends, one wave is given in sine, the other wave is given in cos. So, first of all, what you got to do? Huh?
Change them into change second equation to cos.
Huh?
Sorry,
Change second
sine.
equation to sine.
Second
So, how do
equation
I
to
change it? I write pi by 2 plus. Yes or no? Yes or no?
sir. I think it is minus pi by 2.
I'm not going to go into trigonometry class now. Otherwise, you will get more scolding.
Sir,
Oh,
if it is pi by 2 plus theta, then it will be minus sine, no, sir.
take a deep breath. Take a deep breath. Deep. Open your eyes and see. You will see sine of 90 plus theta is cos theta. I cannot take you back to the year 2017 when you were in 10th standard, right? I have to move ahead at least. And at least I can imagine that you know how much is sine 90 plus theta and how much is cos 90 plus theta. Do we understand this?
Sir, we can write then pi by 2 minus theta.
Go back to the chapter on SHM, see that lecture, and then come back again. I don't have the energy left to argue this. Okay, go back. We have done many questions on sine wave. Go back and see how did we convert. Now, once we know this, don't worry, I'll come back to this question in this class, in the next class. Right now, I don't have energy left for argument. Now, everything is similar. The phase difference between the two waves, is pi by 2 plus phi. You can find out the part difference. Part difference will be lambda by 2 pi into phase difference. And that is the answer, my dear friend, which is option B. Do we understand this?
Yes, sir.
Do we understand how to convert sine into cos and cos into sine? You understand this?
Yes, sir.
Because if I do pi by 2 minus, the entire angle becomes negative. I just can't do that. So I have to just add something. Do we understand this?
Yes, sir.
Thank God. We have understood this, and that takes us to a end of this class. We have understood in today's class that sine of 90 plus theta is cos theta, and that is the biggest achievement of our life. So we will keep that achievement and we'll build on whatever we have studied about these waves in the next chapter, in the next class. Sometimes we do get confused about simple things in life. I even sometimes forget how to I even forget the password of my laptop. So it happens. Don't worry, but we have to learn and we have to be careful because I can make a simple mistake. I am not going to appear in the paper, but you cannot do the same mistake. So I'll see you in the next class and we'll try to wind up this at least wave equation in the next class and see the particle velocity, wave velocity. That is the part that is going to take the maximum time to understand wave. Once we understand wave, everything is going to be simple. So I'll see you in the next class. Take care. God bless all of you. Bye bye.